In this video, I'm going to go over graphing parabolas. Now, parabolas usually make a kind of a U shape, either opening up or opening down. And they have a general form of the function. It goes ax squared plus bx plus c. And a, b, and c stand for number values. Now, before we go over how to graph them from being given, an actual values for A, B, and C, I'm going to go over the different names of the different parts of a parabola that you need to know so that you know what to look for when you're graphing one. All right. So first things first is parabolas have symmetry. So we need to find out the line of symmetry, which is usually the first thing you do. That would be what divides the left from the right, So we have the line of symmetry goes right down the middle. Again, symmetry is like if you had this on a piece of paper and you folded over that line of symmetry, that graph would overlap the exact graph on the other side of the line of symmetry, right? So what does that mean when we find line of symmetry? Well, once we have the line of symmetry, then we can find this point right here, which is called the vertex point. All right. Now, it's also, you could call it the minimum in this case. But if it was opening down, right, it would be the maximum, right? So we just used vertex for both instead of saying minimum and maximum. Vertex. Got it? All right. Well, okay. What are the other parts we need to know about it? Well, we need to know if our parabola crosses the y-intercept, just like our graphs of lines, right? They have a y-intercept, just one, because if they had more than one, that wouldn't be a function, would it? Now, for x-intercepts, you can have more than one x-intercept, and we do. Now, some textbooks might ask you to find the zeros of the parabola. That's what they're referring to. They're referring to the x-intercepts. They are the zeros. Why do they call them zeros? Because in order to find the x-intercepts, you set your equation equal to 0 and you factor it out. And all the different ways we learn to factor is all so we can find x-intercepts of parabolas and stuff. All right. Well, how do we find the vertex, though? Well, we start by finding the line of symmetry, or the axis of symmetry. How do we find that? Well, the x-coordinate of the axis of symmetry is equal to negative b over 2a. My a's look like 9s sometimes. 2a. How do I know that? Well, you remember the quadratic formula, right? Negative b plus or minus a square root of b squared minus 4ac all over 2a. Well, the negative b over 2a is this piece of it, right? And adding this part of it would just give us the x-intercepts, adding and subtracting that, because this is our line of symmetry, right? And we're adding to it to get the x-intercept on the right, and we're subtracting from it to get the x-intercept on the left, right? Make sense? Now, if you had imaginary answers, then I suppose you would have a parabola that just doesn't cross the x-axis, which is perfectly fine. Doesn't mean it's not a parabola. It just means it doesn't have x-intercepts. It's fine. All right, so after we find that, then we can plug that value back into our original formula to find the y coordinate for the vertex. Right? Because negative b over 2a, whatever that x value is going to be our x coordinate for the y coordinate of the vertex, right? That's why I'll say x sub v, y sub v. And then once we have that, and we find the x-intercepts, we have 3 points, and we can graph it. Easy enough, right? One more thing. How do we know if the parabola is opening up or opening down? How do we know? Well, we can just look at our original general form of the equation. It'll tell us if a is greater than 0, it's opening up. If a is less than 0, it's opening down. It's that simple. What if a is equal to 0? Then we wouldn't have a parabola, would we? We would have a line, because 0 times anything would just be 0, and we just have bx plus c, or mx plus b, really. We'd have a line, not a parabola. All right, now that we understand all that, let's do a couple of examples. All right, let's graph this this function here. All right, so what do we do first? We need the x-coordinate of the vertex, right? And that would be negative b over 2a, the first part of that quadratic formula. All right, what's b? Positive 4. So put the 4 in there. And a is what? Just 1. That's easy. Which gives us negative 4 over 2, which gives us negative 2, right? All right. So we have the axis of symmetry, which is this vertical line here at x equals negative 2. Okay, well, if that's the axis of symmetry, then the vertex is going to be somewhere along that line. So we just put that in for x, because it's our x value for the vertex, right? So the y value for the vertex will be negative 2 squared plus 4 times negative 2 plus 3. Negative 2 squared is 4. 4 times negative 2 is negative 8. 4 minus 8, negative 4 plus 3, negative 1. Okay, so our vertex would be at negative 2, negative 1. All right. Not bad. Now, What about our x-intercepts? Well, let me erase this to make myself some room. Now we solve for y equals 0. Right? I just wrote out that same thing, just with a 0 in for the y. That's it. And we figure out what the values, or because there's more than one, values of x are for when y equals 0. And we know it opens up because a is positive, right? So there are going to be x-intercepts. All right, so what adds together to get 4, but multiplies to get 3? Well, positive 1 and positive 3, right? 1 plus 3 is 4. 1 times 3 is 3. Right? We can check our answer by foiling out, right? First, outside, inside, last. X squared plus x plus 3x plus 3. Yeah. Always good to check your work when factoring. 0, right? Well, if either one of these is 0, then the answer will be 0. So you set each of them, don't need parentheses this time, set each of them equal to 0 individually. Quick review of factoring. So our x-intercepts are at -1 and -3. There's -1 right there, 2, 3, -3 right there. That's nice. And we just draw the curve right there, and we're good. Well, I'm not sure about that that y-intercept there. Maybe we should maybe we should calculate that too, right? We want to be absolutely sure of ourselves when we go to draw the final graph. All right, how do we find the y-intercept? Forgot to go over that in my first part of the video. Well, it's easy. X is what at the y-intercept? 0. So y equals 0 squared plus 4 times 0 plus 3. 0 plus 0 plus 3 is 3, so y equals 3. All right? 1, 2, 3. It's up there, not y equals 2. So it's a little steeper than I thought. And since it's symmetrical, this gives us another point. This is 1, 2 spaces away and up 1, 2, 3, 4 from the vertex, right? So 2 over 1, 2, 3, 4 up. So we go 2 over 1, 2, 3, 4 up. And that is our graph of the parabola. I'd say 5 points is very good. It's plenty for graphing parabola. All right. All right, as is tradition, I'll do one last example, and this one will be more difficult than the others. Why do I say that? Well, first of all, our A is not 1. It is positive, though, so we know it's opening up, right? All right. Well, what is our axis of symmetry? or x coordinate of our vertex is negative b, right? And b is negative 5 in this case over 2a. A is positive 2, right? Negative times a negative is a positive. 2 times 2 is 4. Okay. 5/4. Fractions. Oh no. Don't be scared of fractions. By the end of this, you'd say, I ain't afraid of no fractions. Now, what about our y coordinate for our vertex? Well, we plug in 5/4, right? Okay. Wow. All right. Right now you're thinking, oh boy, that's not that bad. 5/4 squared is 25 over 16, right? Multiplying that by 2, don't forget. Minus 5 times 5 is 25 over 4. Okay. Now we can cross cancel these, right? Divide by 2 is 1, divide by 2 is 8. So we're left with 25/8 minus 25/4 plus 2. We need a common denominator before we can subtract these, right? So to get a common denominator, we multiply by 2 over 2, right? Because 4 times 2 is 8. So we get 25/8 minus 50/8 plus 2. While we're at it, let's convert 2 into 8s, right? Multiply it by 8 over 8, right? 16 over 8. So 25 minus 50/8 is negative 25. Plus 16 over 8, right? See what I did there? So we're left with negative 9, right? Negative 9/8 is the y coordinate of our vertex. So the vertex, let me write it down here. Vertex is 5/4 negative 9/8. I'm doing this so that on your test, if you get any fractions, you'll be like, I can handle fractions. So if this is a scale of 1, 2, 3, and so on, we can say 5/4, that's 1 and 1/4, right? It's between 1 and 2, because 2 would be 8/4, right? So about 1 and 1/4, okay. And then negative 9/8, that's just a 1/8 more than 1 in the negative direction, right? So it's about here. That's not too bad. All right, let's erase this. Give ourselves some room. I bet the factoring won't be quite so easy as that, right? Oh, it's fun. All right. Well, first of all, let's find our y-intercept. That's just plugging in zeros, right? That makes that 0, so it's 2, right? So positive 2, that was easy. And since this is our axis of symmetry, and it is 5/4 that way, it should be 5/4 the other way, right? So 1 and 1/4, so about 2.5 should be right there. See how I did that? All right, now the x-intercepts. Because the y-intercept is usually easier to find, so x-intercepts next. We set y equal to 0, and we factor. Now, when a is not equal to 1, we use the grouping method, right? I love the grouping method. Grouping method is money every time. So what is a times c? Well, a is 2, and c is 2, right? So a times c is 4. What are the different factors of 4? 1 times 4 and 2 times 2, right? Now, which ones can we use to add up to -5? Well, we can use the negative version of 1 times 4, right? Because -1 plus -4 is -5, and -1 times -4 is still +4, right? So let's use that one, -1 and -4. So we rewrite 2x squared again, but instead of -5x, we write -1x, which is just -x, minus 4x plus 2. All right? All we did was split that -5x into two like terms. All right? Now, we just focus on one piece of it, and we just factor out the greatest common factor, right? GGCF. So, just ignore that minus x squared plus 2 for a second. What is the greatest common factor of 2x squared minus x? If you said x, you would be correct. Right? You divide this by x, you get 2x. I accidentally wrote the squared there. Again, multiply -x divided by x, you get -1. Divide. All right, so 2x minus 1. Let's hope that we get 2x minus 1 over here as well. So now we ignore this part of it. We say, what's the greatest common factor here? -2, right? The negative is very important because we're dividing both of these numbers by -2. So what's -4 divided by -2? +2, right? +2 divided by -2 is -1. And we get 2x minus 1 both times. And since we're multiplying these two numbers by the same thing, we can then factor out the 2x minus 1, right? And we're left with 2x minus 1 times x minus 2. Okay, now, the rest is easy, right? We just set each of these equal to 0 and solve for x. X equals 2 there, plus 1. 2x equals 1. X equals 1/2. All right. So our x-intercepts are at 1/2 and +2. Just halfway between 0 and 1. Should be easy to find. And +2, that's easy. It's right there. And we have 5 points. We can draw a pretty accurate graph of the parabola. And we're done. And it's just some fractions. It's no problem, right? Thank you for watching.